Hello everyone. As a continuation of method of image, here I am considering a problem which is concerned with calculating the potential energy. This is a previous CSIR problem. Okay, here there is an infinite conducting sheet or a conducting plane which is grounded. That means it is maintained at potential 0. Okay, now there is a charge Q which is at a distance d from this sheet, and let me call its mass is m. Okay, now it is allowed to move under the influence of the field produced by, or it is allowed to move towards this conductor. Okay, now the question is, when this Q is at a distance d by 2 from the plane, the speed of the particle is u. Then what is the distance when its speed is 2u? What is its distance when its speed is u? When it is at a distance d by 2, its speed is u. Initially the charge is at a distance d. Okay, from here it is moving towards the plane. Why it is moving? Because by the method of image, what I can do, when the charge is over here, this problem is alternately converted into like this. Here this is the z-axis. So charge Q is located at D. This is Q. So if you take this as origin, then exactly at a distance of minus D, you will be having minus Q. So when I left this charge, what happens? Due to the force between this Q and minus Q, which is attractive in nature, this Q keeps on moving towards this plane, conducting plane. So because of which its velocity keeps on increasing. Question is, when it is at a distance d by 2, if its speed is u, what should be its distance when its speed is 2u? So to calculate this, okay, I'm going to use the work energy principle. What is the work energy principle? Work done by all the forces. All the forces is equal to change in kinetic energy. If you want a detailed discussion of this work energy principle, you can refer my previous lectures related to work energy principle, which are available in YouTube. Okay, now work done by all the forces is equal to change in kinetic energy. So here the only force which is in picture is electrostatic force, which is conservative in nature. So work done by a conservative force can be represented as negative of change in potential energy. So which is nothing but, in this case, all forces is conservative force only, so therefore minus delta u is equal to delta k, you can write. So when it is at a distance d, its initial velocity u is 0, and its initial potential energy ui is equal to, let me call it as v. Okay, its initial potential energy ui, when it is at a distance d, so its image charge is at minus q is at a distance minus d. So because of which initial potential energy of the system is given by minus 1 divided by 4 pi epsilon naught into q square divided by 4 times d, where d is the distance between the origin and the charged particle. Now when it is at a distance d by 2, according to the given problem, he is telling that speed is u. So v is its speed u. Don't confuse with this u and this u. This ui is initial potential energy, this u is speed of the particle. So its velocity when the particle is at a distance d by 2, okay, its potential energy is given by u1, I am calling it as u1 is equal to, how much you gonna get? Minus 1 divided by 4 pi epsilon naught into q square divided by 4 times. So the distance of the particle when its speed is u is d by 2. That I am writing here as d by 2. Okay, next, third, this is step number 1, this is step number 2. Third step, when v is 2u, okay, let me assume the particle is at a distance z, then potential energy u2 is equal to what I can write? Minus 1 by 4 pi epsilon naught into q square divided by 4 times z. So this is the data that is available. Now at this instant, particle velocity is u, means it will have some kinetic energy which is half mu square. At this instant it is half m into 2u whole square. So now I am applying work energy principle for the first step. When particle moved from d to d by 2 distance, in this case, in this interval I am applying work work energy principle. Work done by conservative force is equal to negative of change in potential energy. That is equal to negative of change in potential energy means final potential energy. When it is at a distance d, this is initial potential energy and final potential energy is u1 for this interval. So uf is how much? Minus 1 divided by 4 pi epsilon naught into q square divided by 4 into d by 2, minus into minus plus because ui is minus is there, 1 by 4 pi epsilon naught into q square divided by 4d. Okay, this is the expression. So work done by this conservative force WC is equal to minus into minus plus, so q square divided by 4 pi epsilon naught, I am taking it as common. So minus into minus plus, what you will be getting? 1 divided by 2d minus, this is 1 by 4d. If you apply this work energy theorem is equal to change in kinetic energy for this interval, when here initial kinetic energy is 0. When it comes to this position, final kinetic energy is half mv square. So half m into u square. This I am taking it as equation number 1. Next I am going for the second step in which the particle is moving from d by 2 to d. In this interval, work done by conservative force, which is nothing but change in negative of change in potential energy, is equal to how much you can write, which is nothing but negative of change in potential energy. That is equal to what I can write, change in potential energy is how much? Final. Here final is d by 2 to, sorry, this is not d by 2 to d. This is moving from d by 2 to some arbitrary position z. This z only I should calculate here. Negative of change in potential energy means negative of final potential energy, that is when charge is at position z, minus q square divided by 4 pi epsilon naught into 1 by 4z, minus into minus plus. Okay, when particle is at d by 2, q square divided by 4 pi epsilon naught into 1 by 4 into d by 2. Therefore, work done by conservative force in this interval is given by minus into minus plus. I am taking q square divided by 4 pi epsilon naught as common. If you take it, you will be getting how much? 1 divided by 4z minus 1 divided by 2d is equal to change in kinetic energy. Final kinetic energy, when v is equal to u, final kinetic energy is 4 times half mu square. So initial kinetic energy, that is when the particle is at d by 2, half mu square. So if you simplify this, what you will be getting? Q square divided by 4 pi epsilon naught into 1 by 4z minus 1 divided by 2d is equal to half mu square. 4 minus 1 is 3. 3 by 2 half, already 3 by 2 I wrote it here, no? M into u square. 3 by 2 times m into u square. This is equation number 2. Actually, I wanted to calculate here the value of z. For that purpose, simply what I will do is I will divide equation number 1 and 2. And for 1 divided by 2. 1 divided by 2 yields. What happens? In equation number 1, q square by 4 pi epsilon naught, q square by 4 pi epsilon naught gets cancelled. 1 by 2d minus 1 by 4d. This is nothing but, again, 1 by 4d you will be getting, because if you multiply 2 it will become 4, 2 minus 1 is 1, because of which it is 1 by 4d. So that only I am writing here, directly I am writing here, 1 divided by, this is 2 minus 1 is 1 only, 1 by 4d. 1 by 4d divided by this one, q square by 4 pi epsilon naught got cancelled. So what you will be left over here? 1 by 4z minus 1 by 2d is equal to this right hand side, half mu square, half 3 times half mu square gets cancelled. You will be getting 1 divided by 3. So in this, again we can cancel out 2 also. Am I right? This is 4, this is 4, this is 2. So cross multiplying it. 3 times, already I cancelled 2. 1 divided by 2d is equal to 1 into this. Already I cancelled 2, no? 1 by 2z minus 1 divided by. Actually, I wanted to calculate z only. That implies 1 divided by 2z is equal to, okay? If it goes 3 divided by 2d plus 1 divided by d. This is how much? 3 plus 2, 5 divided by 2d. In this 2 gets cancelled. That implies z is equal to d divided by 1. This is the answer. So at a distance of z is equal to d by 5, what happens? The velocity of the particle becomes double to its previous case. Here you should be very careful. Every student in hurry, what he will do now? Because the potential energy is 1 by 4 pi epsilon naught k q square divided by some r, no, which is directly proportional to half mu square. And you may be attempted to write u square is directly proportional to 1 by r and dividing and getting the answer. This is wrong. This method is wrong. Why it is wrong? Because here the body is moving under variable acceleration. If it is moving under uniform acceleration, this ratio proportion style you can do it. In this way you can do it. But here acceleration is not constant, because of which you can't solve the problem by this way. You have to apply the conservation of, you have to apply work energy principle and solve it like this.